Hi everyone, welcome to our weekly review video. Last week we did systems of equations word problems, and then we also did systems of three equations. So let's get started. I am on page 15 of our packet if you want to go ahead and turn to this page, and let's try to work on these problems together. Okay? Example 1 says Nora purchases 2 donuts and 3 cookies at a donut shop and is charged $3.30. Mike purchases 5 donuts and 2 cookies at the same shop for $4.95. All the donuts and cookies have the same price. Find the price of one donut and the cost of one cookie. So step 1, whenever we're doing word problems, is to always define our variables. And you can choose any letter you like for your variables, but try to choose letters that make sense. So, for example, in this case, we're looking for the price of a donut and the price of a cookie. So I want to use D for the price of a donut. And try not to just write donut because that can mean a lot of things, right? So D would be the price of one donut. Okay, it's not like how many donuts we bought, because I know how many donuts each person bought. So then the other variable we want to use is C for price of one cookie. Our next step is going to be to turn these pieces into equations. So let's go ahead and start with Nora. I have Nora purchases 2 donuts and 3 cookies at a donut shop and is charged $3.30. So I'm going to translate that into this yellow highlighted portion here. 2 donuts, so 2 times D, plus 3 times C, since she bought 3 cookies, is going to equal to $3.30. Alrighty, our second one is going to be Mike. Mike purchases 5 donuts and 2 cookies at the same shop for $4.95. So let's go ahead and see if we can write an equation for that one. You can go ahead and pause the video, try to write one on your own before we go over it. Alrighty, let's go ahead and try this. So we have 5 donuts, so 5D, and 2 cookies plus 2C has to equal to $4.95. Now that we have a system of equations, we can either use elimination or substitution. If you're taking a look at this equation that we have set up, the best method to use would be elimination because we don't have any of the variables solved for. Okay, in order to use elimination, we must multiply. So I'm going to multiply the top by 5 and the bottom by 2. Before we distribute, we do need to realize that they need to be opposite coefficients. So you need to make one of them negative, okay? I'm going to make, let's make the bottom one negative. And now let's multiply. Let me pull out my calculator. Okay, I'm trying to adjust this. It looks weird. Okay, so 5 times 2 is 10. D plus 5 times 3 is 15C equals 2. Here's where I need my calculator. $3.30 times 5 is 16.5. Same thing on the bottom. Negative 2 times 5 is negative 10D. That's how I know I'm on the right track right now because we have opposite coefficients. Minus 4C equals 2. 4.95 times 2 is negative 9.9. Let's go ahead and add straight down. So if I add straight down, my donuts will cancel out. I'm going to be left with 11 cookies equals to 16.5 plus negative 9.9. That gives us 6.6. Divide by 11 on both sides. The cost of one cookie is going to be 0.6, and that means 60 cents, guys, not 6 cents, okay? So be very careful of that. We now still need to find the cost of a donut. We can go ahead and use one of those original equations we created. Whichever one you like, I'm going to use the one with smaller numbers. So that's 2D plus 3C equals to $3.30. We already know the cost of a cookie, so let's replace that. So instead of C, we're replacing it with 0.6. Okay? Distribute. So let me highlight the steps as we go. The first thing we're going to do is multiply this. 3 times 0.6 is 1.8. Now we're going to subtract 1.8 from both sides. I get 2D is equal to 1.5. Divide by 2 on both sides. We get D is equal to 0.75. So this kind of makes sense to me, right? A cookie costs 60 cents and a donut costs 75 cents. We want to make sure we don't get answers that are negative because that wouldn't make any sense. And, just a donut shouldn't cost like $75. So again, you're looking for reasonable answers. Let's rewrite our final answer. 1 cookie costs 60 cents and 1 donut costs 75 cents. All right, let's go ahead and try the next problem, but I'm going to pause in between. I want you guys to pause, and I'll give you cues on to when, so that way you can try some of it on your own before we go over it. Okay? The owner of a movie theater was counting the money from one day's ticket sales. He knew that a total of 150 tickets were sold. Adult tickets cost $7.50 each, and children's tickets cost $4.75 each. If the total receipts for the day were $891.25, how many of each kind of tickets were sold? So again, we need to set up our step 1, define our variables. Let's see if you can pause and define your own variables before we go over it. Unpause when you are ready. So I'm going to have A stand for the adult tickets, but what about the adult tickets? It's not the cost, right? It's how many were sold. So A is going to be adult tickets sold. Okay, and then let's do the same thing for C will be children's tickets sold. Children's tickets sold. Again, it's not the cost, right? It's how many are sold. This one might be a little bit tricky. I'll give you guys a hint. Let's see if you guys, and this will be the easier one. Adult tickets cost $7.50 each, and children's tickets cost $4.75 each. If the total receipts for the day were $891.25, that's going to be your first equation. Okay, try to make that make sense because, again, all of those numbers deal with money. So when you are ready, unpause and let's go. So adult tickets are $7.50 each, so that's going to be $7.50A. And children's tickets, so 4.75C, is equal to $891.25. Could have done a little bit better with that. Okay. And then let's see if you guys can write the other equation. This one's a little harder because we only have one number. He knew that a total of 150 tickets were sold. Think about how you can write that with our variables. I sold a total of 150 tickets. That's going to be the number of adult tickets plus the number of children's tickets has to equal to 150. Now, you could definitely use substitution for this. You would have to take that green equation and try to solve for one of your variables. I'm just going to continue using elimination. So go ahead and pause the video, and when you're ready, you can unpause it so we can go over this problem together. All right, so the first thing we're going to do is we have to multiply. At the top, we're going to end up just multiplying by 1, since that's the coefficient on my bottom. On your bottom, I'm going to multiply by negative 750, so that way we're going to have negative coefficients. My top equation stays the same. I get 750A plus 4.75c equals to $891.25. My bottom equation becomes negative 750a, and that's great because I needed opposite coefficients, minus 750c equals to, let's multiply this out, 150 times negative 7.5. We get negative 1,125. Go ahead and add your two equations together. So 4.75 plus negative 7.5. We get negative 2.75c on my left side. And remember, we don't want a negative answer. Hold on, let me just do this before I say anything. So 891.25 plus negative 1,125. We get negative 233.75. So right now, you might be a little confused as to why we're getting a negative number, and that's okay as long as our final answer is not negative, okay? And it ends up being positive because we're going to divide by negative 2.75 on both sides, which will make our right side positive. So take that number, divide by negative 2.75, we get 85. So we sold 85 children's tickets. You need to solve for the number of adult tickets. Again, choose the easier equation. In this case, it would be the bottom one. A plus C is equal to 150. A plus C is equal to 85. So let's replace that. Equals to 150 minus 85 from both sides. Can't even do that in my head. 150 minus 85, we end up getting 65. And again, these numbers make sense to me. Neither of them are more than 150. They add up to 150. Okay, they're not negative. So let's rewrite our answer. How many of each type of tickets were sold? There were 65 adult tickets sold. And 85 children's tickets sold. All right, there are more word problems for you guys to practice, but we're going to go ahead and move to our systems of equations, okay? So join me on page 21. We're going to look at this example together. The first thing we want to look for is we want to look for coefficients that are the same. So the numbers in front of the variables are the same. So we have in front of our x's, you'll see those are not the same. So we really don't want to eliminate that. In front of our y's, those numbers are not the same either. But then if you take a look in front of our z's, let me use a different color. We have the same coefficient, which is 1. And we can try to eliminate our z. So when we're trying to do that, you want to combine opposite coefficients, right? So for example, I can combine equations 1 and 2 because there's one positive z and then there's a negative z. So let's see what happens when we combine them. 2x plus y plus z is equal to 15, and then 6x minus 3y minus z equals to 35. Let's add these two equations together. I end up getting 8x minus 2y, the z's cancel out, is equal to 50. Hold on to that one, okay? And now let's do the same thing. What other two equations can I combine? We can combine equations 1 and 3, right? Because again, 1 and 3 have opposite coefficients. So 2x plus y plus z is equal to 15, and then 3 is negative 4x. Plus 4y minus z equals to negative 14. Go ahead and try to combine these. Let's use blue. 2x and negative 4x gives us negative 2x. Y and positive 4y gives us positive 5y. The z's cancel out, and this gives us 1. Now what we're going to do is we're going to take these two new equations and rewrite them down here. 8x minus 2y is equal to 50. And negative 2x plus 5y is equal to 1. Now we just have a system of two equations, which we did last week, which we just did with our word problems. All we have to do is solve this equation by elimination. Gonna multiply my top equation by 2, my bottom equation by 8. Multiply my top equation by 2, I get 16x minus 4y equals to 100. Multiply your bottom equation by 8, we get negative 16x plus 40y equals to positive 8, and now we can add straight down. Our x's will cancel out. We get 36y equals to 108. Divide by 36 on both sides. I believe you get 3, but let me just double check. You get y equals to 3. We, however, are not done. This is a system of equations, meaning we have multiple equations, so we're going to have multiple answers for each of our variables. Go ahead and take one of those baby equations that you made. I'm going to use the one in green, okay? So I'm going to do 8x minus 2y is equal to 50, and now I know what y is. I can plug in for y. So this is 8x minus 2 equals to 50, and we're plugging in 3 for y. So this is 8x minus 6 equals to 50. Add 6 to both sides. We get 8x equals to 56. Pause the video at any time if this is going too fast, and just make sure you're really grasping what's understanding. Divide by 8 on both sides. We get x equals to 7. We are still not done because we have 3 variables. So now I need to solve for z. How could I solve for z? We need to go back to one of the original equations. So one of those big equations on top. I'm going to choose that first one because all the numbers look positive, which was 2x plus y plus z equals to 15. Okay? Let's see. Our x was 7, and our y was 3. Okay, so if I go ahead and distribute, I end up getting this is 14. Bring down the 3, bring down the z equals to 15. Combine like terms, 14 and 3 gives us 17. Plus z equals to 15. Minus 17 on both sides. You get z equals to negative 2, and we are done. Okay, if you want to write your final answer, remember we write it alphabetically. X comes first, 7, and then y, which is 3, and then z, which is negative 2. There are more problems for you guys to practice as you go. Just remember that when you're looking to eliminate, you want to look for the variable that will be easiest to eliminate. So if you want to try this next problem, the easiest one to eliminate would be our y's. Okay, since you see those 4 4s and 4s. All right, well, thank you for joining me today. If you have any questions, remember you can always email me, text me, leave a comment, ask me in class. Otherwise, again, thank you for watching this video. I really appreciate it when you guys take the time out to try to do something better for yourself. I will see you in class. Have a good day. Bye.